Hey everybody, welcome back. Today we're going to talk about Chapter 3, and Chapter 3 is all about functions, and specifically linear functions. Now, I'm going to adjust my camera a little bit higher there. There you go. It's going to take a little bit of getting used to, but it's really not going to be too bad. I don't know if you learned about this in 7th grade or 6th grade at all, but if not, I'm going to give you kind of half of Lesson 1 today, and we'll do the second half tomorrow. So here we go. Here are just some vocabulary words that we'll need to know for today. Functions can be broken down into a couple vocabulary words. The first one is a relation. Everything that you have seen probably ever is a relation when it relates to two things being connected, right? Any pairing of input and outputs, everything that you have ever done in this class or any of your other classes could be called relations, right? Any of this stuff down here, equations, tables, graphs, order pairs, this is called a map. All those are relations. Everything is a relation, at least that we've seen so far. So now there are special types of relations called functions. And now they have a very specific rule, and this is the most important part of today's lesson to know what this is. A function is a type of a relation which pairs each input with exactly one output. That is the most important part right there. Each input has only one output. Each input pairs with one output. That is the most important part to have in your memory bank for today. And so here are the different varieties, the different ways they can represent relations and functions. They can do equations. We're actually going to save those for another day. They can do tables. That's very, very common. Graphs. We're going to talk about graphs today. Ordered pairs. You've seen ordered pairs for a long, long time. These are called maps with little arrows. It's basically the same thing as this. Over here, they just kind of do it a little bit differently with arrows. So that is our vocabulary for today. Everything is a relation, but then there's special type of relations called functions. And our goal today is to figure out, are these relations functions, right? So is this, I have four different relations here, four different combinations of x's and y's, of inputs and outputs. Are these functions? Okay, how do you determine it whenever it gives you a list of ordered pairs? Could you graph it and see what shape it makes? Sure, but is it actually faster to do a different way? Yes. Remember our rule. Each input can only have exactly one output. Now the inputs are like the inputs are the x coordinates, right? You know how you have like the x coordinate and the y coordinate? So the very first number in each ordered pair, the x coordinate, is technically called the input as well. You just never really hear teachers refer to it like that in 5th grade, 6th grade, 7th grade. So does each one of these only pair up with one number, right? Let's just check. -2, this is the output right there. -2 pairs up with +2. -1 pairs up with +2. 0 pairs up with +2. Now, we're getting a lot of these outputs. All these outputs are the same. 1 is pairing up with 0. And here, the number 2 is pairing up with 0. Don't get hung up on the fact that the outputs were the same. The key question is, does each input only have one output? Does -2 only have one output? Yeah, it does. -2, there's no other -2's in here as the input. -2 pairs up with one answer, and that's 2. -1, does it only pair up with one answer? Yeah, there's no other -1's here. 0, does it only pair up with one answer? 0 pairs up with 2. And I don't see any other zeros in this list as inputs. You'll really start to notice whenever you have the inputs repeating that you have a problem. Here, the number 1, +1, pairs up with 0. I don't have any other instances of +1 pairing up with a different number. And here, +2 pairs up with 0. Now, they're pairing up with the same number, but that's okay. Is this a function? Yes, this is a function. Now, let me show you one that's not a function, because you're probably like, what? That was really confusing, man. I don't even know what you just talked about. Here's an example where it's not a function. Look at this one. 4 pairs up with 0. The input 4 has an output of 0. The input of 8 has an output of 7. The input of 6 has an output of 4. The input of 4 has an output of 3. And here the input of 5 has an output of 2. Did we ever have an instance where the input had more than one output? And I think if you look carefully, you'll see that we actually did, right? Look right here. 4 pairs up with 0. Okay, that's fine. I don't have a problem with that. 8 matches up with 7. I haven't had any repeats yet. 6 matches up with 4. And then here's our problem. Look, 4 pairs up with 3. Why is that a problem? Well, look what just happened a little bit earlier at the beginning of this, right? Right here, the 4 pairs up with the 3, But look at the very beginning. Here the 4 pairs up with the 0. You see how the 4 has 2 different outputs? Right here. The 4 at the beginning matches up with 0, and then a little bit later down the line, 4 matches up with 3. That is not allowed if you want to be a function. The input 4 has 2 different outputs. One time it's 0, and then later on, now it's 3. That is illegal if you want to stay as an output. So you've got to have inputs not repeating themselves. Anytime you see the input, this x-coordinate, repeat itself, you've probably got a situation where you do not have a function. Okay, hopefully that makes it a little bit easier to tell. Let's kind of buzz through these others. Here, -5 pairs up with 0. No problems there. 0 pairs up with 0. Okay, kind of weird, but that's all right. My inputs haven't repeated. Look here, +5. Now, these are different. This is -5 and this is +5, so we're still okay. And uh-oh, here's our problem. 5 pairs up with 10. So look what we have right here and right here. The number 5 in the input section as the first number in the parentheses has matched up with 2 different outputs, 1 times 0, 1 times 10. So this is not a function. No, that is not a function. And then one more down here. -4 matches up with 8. -1 matches up with 2. +2 matches up with 4. 5 matches up with -10. I didn't even have any numbers repeat in this. All of my inputs are different. Look, -4, -1, +2, +5. That is completely good. This is a function. Okay, hopefully that kind of clears it up a little bit. Remember, the key thing to look for is, does the input ever show up twice, right? Do you have the x-coordinate show up more than one time? That is kind of your big giveaway. Okay, other ways they can write functions, they don't always have to do the list of ordered pairs. They could do something like this. Don't let this bother you. It's basically the same idea. All right, this is the same thing as listing out -2, 3, -1, 4, 0, 5, 0, 6, 1, 7, and 2. It's the same way as if they would have listed them out like this, right? It's the exact same thing. I'm not going to write them all, but that's basically what they're doing. So if they give you an x and y table, sometimes they'll put x's and y's up here to represent inputs and outputs. The x's are the inputs and the y's are the outputs. Just kind of look. -2 pairs up with 3. Okay, that's fine. -1 pairs up with 4. That's fine. Here, look what you have, though. You have a problem. Look, the number 0 has 2 different outputs. Here the 0 goes with 5, and here the 0 goes with 6. So this is not a function because the number 0 had 2 different outputs. This one is very, very simple, but this one is good, right? -2 goes with 2.6. I'm sorry, not negative. 2 goes with 2.6. 4 goes with 5.2. 6. These are all different numbers. When none of your inputs repeat, you are good. You have a function. Over here, this one looks very strange, but remember what we're concerned about. Do the inputs ever have more than one output? Does 1 ever have more than one answer? No, it's only got one answer. Now, all these are the same answer. They're all matching up with 0, but is that okay? Does each input only have one output? Yeah, 1 only has one answer, 2 only has one answer, 3 only has one answer, 4 only has one answer, 5 only has one answer. So this is completely fine. It looks weird, but each input, my input's never repeated. Here, sometimes I'll draw it with one of these little maps. It's still going to be the same idea. Just look at the arrows. Here, -1 is only paired up with one number. 3 is paired up with one number. 11 is paired up with one number. Now, these two are pointing to the same number, but is that okay? Yes. Look, my inputs only have one arrow, one arrow, one arrow leading off of them. That is okay. But here's where it gets to be not okay. Look at a situation like this. The 3 pairs up with one answer. Look at right, here's our problem. Right there. You see how the number 4 has 2 different arrows shooting off of it? This input has 2 different outputs. The 4 goes with 0, the 4 goes with 4. So this is not a function. Okay, there's the difference. Okie doke. The very last thing they will do is they will give you graphs, or the last thing we're going to do today. How do you tell if a graph is representing a function? There's something called the vertical line test. And basically what you do is you take a vertical line and you try to draw it through the shape, right? And if a vertical line, any of your vertical lines ever touch the graph in more than one place, you do not have a function. Like here, I'm drawing vertical lines. I like to do them kind of dotted so they don't mess up the graph. No matter where I put these vertical lines, do you see how it's only touching it in one spot, right? It's only intersecting in one spot. If it goes like this, where your vertical lines only hit it one time, then it is a function. My marker's kind of dying on me there. Yes, that is a function. But look at an example like this one, right? Right off, like here, if I do a vertical line, okay, I miss it completely. If I get a little bit closer, there a vertical line maybe touches it in one place. But look, right here, boom, boom. This vertical line touches it in more than one place. Even if I did it out here, which you don't have to, boom, boom. If a vertical line, if a single line touches it in more than one place, it is not a function because this input right here matches up with two different outputs. Okay, sometimes they aren't connected for you. They're just regular dots. And so you kind of do the same idea. Does each one of these, like if I drew a vertical line through the dots, right? This is legal. All these are good. All these are good. Now, if they would have done something like this one is actually yes. There are no situations where my vertical line is touching it more than once. But if they would have done something like this and put another dot, like right there, then this little spot right here would have been no, because you've got these places right here that touches it more than once. But that wasn't really there. I made that up. Okay, some other examples, and then we'll give these a try on the class website for Big Ideas Math. Okay, are these functions? Quick, you can usually tell these in about 5 seconds, right? Is a vertical line going to hit this in more than one place? No, no, no. My vertical lines are only hitting them once, so is this a function? Yes. This one, this is called a parabola. That vertical line touches it once. This vertical line touches it once. This vertical line touches it once. Can I ever find a spot where a vertical line touches it in more than one place? Even here, it basically only touches it one time. So this is okay. If I drew that perfectly, it shouldn't go straight up. It should kind of gradually go to the side. So I apologize if my graph didn't look very good. Here, look at this guy. Oh, geez, right off the bat. No way. Look, vertical line hits it in 2 places. That is not a function. No way. This kind of looks like a check mark. Absolute value graphs kind of look like this. Look at these. No matter where I put these lines, one spot, one spot, one spot, one spot. Even if I go right here and it touches it right at the bottom of the graph there, this is definitely going to pass the vertical line test. It passes. I don't have any instances where a vertical line touches it in more than one place. Same thing here. One spot, one spot, one spot, one spot. This one is fine. And then, whoa, this guy over here is going to be an issue. Look at that, right off the jump. My vertical line touches it in 2 places. So this fails the vertical line test. That is not a function. Now, all of these are relations. They're all relations, but none of these are functions. So I'm going to stop right there, guys. Feel free to rewind this video. There's other videos out on YouTube. If mine doesn't make sense, you can probably look up as well. But feel free to rewind it, pause it. I'm going to put some questions on the Big Ideas Math site here in a second that kind of have you practice determining if something is a function or not. All right, I'll catch you all in a little bit. Have a good one out there.